Welcome back to the Aussie Shed, ladies and gentlemen, where today things are about to get a little bit nerdy. Today I'd like to talk to you guys about measurements, and specifically what I'm talking about is measurements that you need to take in the engine block when you are embarking on a rebuild or refresh of your engine, which will help you know where you are with things, what parts you will need, and how you are going to progress with your rebuild. What I'm going to show you how to do here is to draw yourself out basically a map using numbers and calculations to get the exact size and shape of all of your cylinder bores and your pistons, work out the clearances, whether you can reuse your pistons that you have on hand, whether you need to get your engine rebored and need new pistons, or whether you'll be able to just hone your engine block the way it is and get by with that and just fit new rings, whatever. But to do any of that, you will need to know all of that sizing and have a record of it. Now, a lot of people don't bother doing this. They just hand it off to a machine shop and just kind of go in it blind and just say, oh, here, whatever you reckon. But, as I try to push people on my channel, it's all about learning, teaching yourself how to do stuff, even if it's basic stuff. We've all got to start somewhere, and you can progress through to more technical things later on as you get more used to these things. But it's good to know exactly what's going on with what you're doing and where you're spending your money. And also to be able to formulate your own plans moving forward than having to rely on someone else to tell you what you need to do. And to do all that, you need knowledge. And to get that knowledge, you need information. And this is where I come in. I'll show you guys how to do all this sort of stuff. So with me particularly, with this engine, as you would know that I've pulled out of the Fairlady, it was a used engine, supposedly low kilometres. It was a built motor that supposedly had a lot of money put into it. There are a lot of promises with this engine, and some of it I can't complain about, honestly. It's really not that bad. It certainly could be better, but it's certainly not the end of the world as well. So what I'm in the process of doing is, the engine is all torn down now, and most of it's been cleaned up. And moving forward, I need to know what exactly I have to do, what machining steps I have to get done, what components I need to buy, what stuff I can reuse, and this is the way to do it. So currently I'm working on the bottom end. I'm working on pistons and the cylinder bores. So the first thing we need to do is we need to know the size of our existing pistons. So this is the piston and rod combination that I pulled out of this engine. You can see they're Wiseco forged pistons, Eagle rods. A nice little unit, nice little setup. Just a rough measure of the cylinder bores tells me they're 87.5 mil, just taken with a set of vernier calipers. Standard bore size is 87, I think. So obviously the engine block's been bored, and these pistons bought for it and set up. But the engine has done some miles. From what I've been told, that's about 10,000 kilometres. But I don't really hold any faith in what I've been told, just because there's been so many anomalies with all the information I've received about this engine. And upon tearing the bottom end of this thing down, I did notice that there was some very light scoring on some of the cylinder walls on the thrust sides of the cylinders on the banks. And I'd like to be sure that they can be honed out and that there is enough meat left in the cylinder walls to properly hone the block, get the right hone finish on the cylinder walls, and not be opening the block up too much. I've got a bit of a feeling that the block is actually a bit tight anyway, but the only way I'm going to know is if I accurately measure everything. So the first thing we have to do is we have to measure our pistons that we've pulled out of there. As I say, these are for an 87.5mm bore, which is what the bore measures to roughly with a set of verniers. But we need to know the exact size of these pistons, and we also need to know how much clearance the manufacturer specifies between the piston and the wall of the cylinder bores. Now, these Wiseco pistons, the manufacturer recommends that they are to be measured 90 degrees off the pin face. So here, on this lower area down here, right down there on either side. So that's our width. Of course, these pistons do taper out slightly at the bottom, and that is the width there that we use to make all of our calculations with. So the very first thing we need to do is we need to mark. See, this is piston number 1. We need to mark and measure all of the pistons so that we know exactly how big each piston is, because you can get some variation, particularly in factory pistons. I've already measured these pistons. They are all exactly the same, but for the purpose of this video, I'll show you guys how we go about doing that. So what I have over here in the vise is a micrometer. Now this is I think it's a 75 to 100 micrometer. Micrometers come in various sizes for measuring different things. This is only a fairly cheap micrometer. I have checked it to make sure that it is accurate. Currently it is accurate, but the measurement isn't really the important side of this anyway. You can actually use a micrometer with a broken dial if you want, I guess, because as I say, the measurement isn't the most accurate thing. Obviously it's good to know, but really what we're going to be working out here is the clearance between the piston and the cylinder wall. But obviously it's good to know the working measurements. So this is how we go about doing this. So it's always good to mount your micrometer in something. Currently I have this micrometer mounted in a set of soft jaws, only very lightly in one of my vices. You have to be super light with these, because mounting it, you can actually distort the micrometer, distort your measurements, particularly with a cheap micrometer like this one. You have to be very, very careful. Mount it just as lightly as possible, that it's just going to stay there. I actually have a set of rubber jaws that I often use for things like this, but as I say, I am being very, very careful. And the reason for that is because you need to be able to, you know, really take both hands to do this. You need to control the piston, and you also need to be able to crank your micrometer. So when you use the micrometer, always use the ratchet. I'll just wind this up. They have a ratchet on the end. Hear that? So that always gives you a concise amount of pressure when you are turning the measuring part in, so you don't over torque things when you're doing it. In a situation like this, I tend to, and it'll take a few goes before you've got it in the right spot. You've got to kind of move it in and out, and you know, try and get it situated as best as you can, so that you have it in a spot where it's firm, but yet you can move it in all directions so that you know you're in the right spot. Otherwise, you know, like if you don't have it situated correctly, it'll be either tight in there, you won't be able to move it around, or it'll be too loose or whatever. You've got to get it so it's just snug, but yet you can turn it, you can move it in and out, and all is good. So when you get it to that point, this, if you're using the ratchet, it won't actually over tighten it. You should still be able to move it when it's all ratcheted. So that's the right spot there. I've got that in the perfect spot. Once you get your position set like this, take note of the measurement, take your piston out, write the measurement down with the corresponding number of the piston, then move on to the next one. And once you have all 6 pistons done, you can then start the process of going through the cylinder bores. Now, all these pistons are exactly the same size. I've already measured them. They're all 87.435. So I can lock this off right now by turning the little handle that way, like so. Lock that off. And then we can move on to the next step. So this is the next tool we'll be using, guys. This is a bore gauge. Now you can buy these pretty cheaply on eBay and Amazon. And what I'll do, I'll leave a link in the description to a bore gauge and a cheap set of micrometers, just to help you guys out. So if I remember, if I forget, make me aware of it in the comments, and I'll leave you some links to some of these on eBay. Anyway, so, mate, honestly, these sets of these things are only like 40-50 bucks. But the issue with them is they come with a cheap gauge on them, a cheap clock, cheap dial indicator, whatever you want to call it. So really they are the accuracy part of the whole setup. So the bottom is just like a pivoting thing that pushes the rod up into the dial indicator. So the dial indicator is where all the accuracy is. These things come with like a really pretty cheap and nasty dial indicator. So you can see I've got one of my Mitutoyo dial indicators on there. So this thing is now incredibly accurate. It you know, works really, really well because it's just a mechanical device, basically, very simple one. All the accuracy, as I say, is in the dial indicator on the top. So these come with different attachments here to work with different sizes. I think this set is a, there we go, just had a look, 50 to 160 mil you can measure bore sizes with. So this is the piece on the back of it that makes it work, and that just pushes in and out. It's only a very little tiny bit of movement, so that's why you have these adjusters, and these are little spacers, so it helps to position it properly in the bore so there's no wobbliness about it or anything. So I'll just push the bottom with my finger, and you can see that's that does when I push that little button in. It just moves the dial indicator. So as you move this into the bore and position it, it will give you the measurement of the cylinder bore. Okay. So, how do we set this up? Now that we've got our micrometer positioned over here in the vise, we now use that to set up the dial indicator in the bore gauge. So, with our micrometer positioned firmly, we now want to set up the bore gauge. Now this takes a little bit of finesse, guys. What you have to do, now this is just a little bit awkward for me because I have the camera right there. I can't kind of bounce around here like I normally would do. So what you have to do, you can see as I'm moving this around, like it's moving. So what I generally do, set the dial gauge onto 0, double check by making sure this is positioned exactly on the anvils, and then just go up and down, up and down. You can see I'm getting a little bit of movement there. It'll peak and then it'll go back the other way. So take a while doing this, guys. This kind of stuff takes lots of time because you are working with really high accuracy, so don't be afraid to take your time. It really is all about chilling out, just taking time and getting this right. So I'm pretty confident that I have my bore gauge now set to 0 on the micrometer. Alright, we can now take that off there. So I'll just put this down over here for a second, carefully, so we don't want to disturb it. We have to be very careful with everything. And sitting just over here is our cylinder block. So with each cylinder we need to take 6 measurements. Now what we're working with is measurements that are 90 degrees to each other. So we need to take measurements across the cylinder bore this way in 3 positions. So at the top, about 10 mil down, just below the ring height, the center of the bore, and the bottom of the bore, just where the ring wear stops down on the bottom of the bore, just below that, or just above that, or right on it. Depends on where you want to take it. So you want to take 3 measurements down that way, and that's called the thrust side, okay, because your crankshaft spins this way, so you've got thrust acting in this way on your pistons, which are then acting on your cylinder bore. And then you've got 90 degrees off that, which is the non-thrust direction, forwards and backwards with the engine. There is no thrust in that way. So you've got thrust, non-thrust. You also want to take 3 measurements in the non-thrust direction. So top, middle, and bottom. And you need to write all of those measurements down. Personally, for myself, I actually take another 6 set of measurements as well from a different perspective. So I'll show you my sheet that I've knocked up over here on the computer. It's just a spreadsheet that I've turned out, but I'll give you a look at that. Alrighty, so I don't know if you guys can see that. Oh, I reckon you probably can. Coming closer so you can stop it and pause it if you want. And I'll scroll up slowly so you can see everything that's on there. Alright, so this sheet gives me a full map of the pistons and bore sizes that I currently am working on this engine. I also have here the weights because I have been weighing the pistons as I do them. You probably saw there is a little scale sitting over here on the bench. So each piston and rod combination gets weighed as I'm doing them. Normally you'd weigh the pistons and rods separately, but they're already attached together. The pistons have markings on them from the factory, I think, or from the previous engine build, which has the weight of each piston. So I can quite easily get the weight of the piston from the markings, get a total weight with a scale, do a calculation, get the weight of the rod, and check how well the piston and rod assemblies were put together as far as balancing goes, and how well they're matched and balanced and all that sort of stuff. So you'll see here what I've done. So this is you can see there I've got piston weight as marked in grams, 1, 2, 3, 4, 5, 6. Piston weight with conrod in grams down here, 1, 2, 3, 4, 5, 6, and then I've got conrod weight in grams. So that is just a calculation of, you know, the overall weight minus the weight that's marked on the pistons, right? So that tells me how well they were put together, and if there is any improvements to be made by swapping any of the rods around or anything like that. Normally you'd do that with the components individually, but in this situation they're already together. So you know, that's just what I've got while I'm here. I may actually separate them and reweigh them later on in the stage, but for now that's sort of all I'm doing with them. So you can see the measurements that I've got here. So what this first line we have here, so obviously I've started measuring on the thrust side, okay? So my thrust side measurements go all the way down to here where we say non-thrust side. So this is cylinders 1 through 6 on the thrust side, and these are the measurements that have been made. So we have cylinder top clearance in millimeters for each piston or each cylinder. Then we have the calculated cylinder top bore size. So that number is achieved by adding this amount to our piston diameter, and that will then give me the cylinder bore size in millimeters in that position. Okay, so we've got 1 through 6, and then I've actually been through them all again. So we'll actually disregard that one for now because that might confuse you guys a little bit. So we've got the middle clearance in the cylinder again on the thrust size, and then again we've got that calculated bore size in millimeters in the middle. Then we've got the bottom clearance in millimeters, the calculated bore size in millimeters, and then we've got the same thing on the thrust side. Now this extra measurement in here that I've sort of skipped over there, so that's a measured top bore size in millimeters. So how I've measured this bore size is where it says measured bore size, okay, and compared to calculated bore size. How I've achieved that is, so I've set the micrometer to 87.5, which is the specified bore size for these pistons. I've then set the dial gauge up to that, and then I've checked that in the cylinder bores. So that will then tell me how much smaller the cylinder bore is than 87.5 millimeters, and I've then subtracted the size of the pistons. I've then added the size of the pistons to that amount. So that's then given me a measured bore size as opposed to a calculated bore size from the previous set of calculations. Basically, it's just a way of double checking the calculations that I've already made. and I have got some discrepancies between them. As you can see here, where are we? We'll just keep working with these top ones. So here you go. This is cylinder 1, so that's the calculated size there of the bore at the top in cylinder 1 from our first set of measurements, and that's from the measured set of measurements. So you got 87.49 compared to 87.477, and you can see as they all go across, they all vary. Some of them are very close, well, they're all very close, but some of them vary more than others. So there is some error in my measuring that I'm picking up here and there. They're only in the generally in the hundredths of a millimetre, so it's not a whole heap to sort of worry about. But basically all of these measurements I'm taking, they're really only preliminary measurements anyway. They're not for machining purposes, they're only for myself, so I can constantly refer back to these numbers as far as making any decisions about what I'm doing with the engine, what parts I need, how I'm moving forward, etc. So the purpose of taking these measurements for me was to tell me whether I can reuse these pistons, whether there is enough meat left in these bores so that I can just rehone them, or whether I would need to rebore the block and go up to the next size piston and all that sort of stuff. So how do we do these measurements? I'll just reset up the camera and we'll have a bit of a look. Alright guys, so if you haven't used a bore gauge before, this is what you do. So you position it in the bore in the place where you need to measurement. So this first measurement I'm doing here, this is cylinder, where are we? We're on the back of the block here, so that's, what's that? Cylinder number 6. That's the only, you've lots of things to remember, guys. That's the only thing about this. There is, it's very easy to lose your place and bugger stuff up. Don't for a minute think that this is super easy stuff to do, and if you're struggling with it, don't be hard on yourself, because it is quite tricky. There is just lots of finesse about it, and even if once you've been through it and completed all this and things just don't seem to add up, don't discount the fact that you could have just completely buggered it all up, no matter how much care you thought you've taken. But you will get better at it very, very quickly. And if taking precise measurements isn't something you're used to doing, it will take a little bit of time to get good at it, to get your hand in. It's just one of those things, and even when you initially start doing it, you will kind of feel that you're going really good until things just kind of don't really add up at the end, and then you'll realize that you are possibly not really doing things 100% accurately. So it's all about fine-tuning and consistency with how you take everything and repetitively doing every single step the exact same, in the same spots, in the same way, consistently over and over again, and writing stuff down accurately. Okay, so let's get to it. So we want to know this distance across the top here. So we have our bore gauge set up to the size of one of the pistons, and when we fit it in the cylinder bore, this will show us how much clearance there is. So if you remember, the gauge was set on 0 when we were on the micrometer at the top. And basically what we have to do is rock the micrometer forwards and backwards, and the dial will peak and then drop off. So as we go forward, if we go past the point where it peaks, it will actually drop off. We come back the other way, it'll hit that peak and drop off again. And that peak is our measurement that we're after. This dial indicator has increments of 0.01 millimeters, and we are 9 of those increments away from our 0 mark. So what we do is we write down 0.09 in our notes, and then we move on to either the next cylinder or the next position, depending on how we are going through and tabulating these measurements. So if we're going to continue on this cylinder, measuring in the non-thrust direction, we now drop down to the middle of the cylinder, do the same thing again. We go forward until it stops and starts to go back down, then pull it back the other way and keep rocking it till we find that high spot. So you can see there that that is on about 6.5 increments back from 0. So I would write down 0.065 for that measurement. Then from there we go down to the bottom of the bore, and I just use my fingers underneath to feel about 15-20 mil from the bottom of the bore, but always make sure you measure about the same distance down on every cylinder every single time. Again, same deal, rock it forwards and backwards. Alright, so we get going forwards until it drops away, go back until it drops away. So that's on just over, slightly over 6 increments away from 0. So we'll call that 0.062 millimeters, and we will write that down. So that's how you take your measurements. As I say, it does take a little bit of finessing to be able to repeatedly take these measurements, and you'll know once you get the hang of it. I haven't done this myself in quite a while, quite a number of years actually, and it took me a little while to get a little bit of match fitness back up before I was confident that I was actually measuring things accurately. And I actually have done quite a lot of this in my life. So if you're doing it for the first time, I can't stress enough, just take it easy, and you may have to redo all these measurements quite a few times until you find that you are getting consistency and you are quite comfortable with it. The best thing to do is go through, make all the measurements, write them all down, and then put that paper to one side, and then do the whole lot again, and then compare them. And if you do not have consistent measurements, then there is something you are doing wrong. Whether it is in your initial setup of your micrometer in relation to either the pistons or how the micrometer is set up with the bore gauge, or whether it is due to how you're actually measuring your cylinders. Until you can repeatedly get the same measurements out of those cylinders, after going through it a few times, then you know you're not on the money. But you'll know as soon as you are. It'll become quite apparent that you can all of a sudden reproduce those same measurements time and time again, no matter how much you skip between cylinders. So anyway, so you go through and you measure your 3 spots in this direction, which is the non-thrust direction, and you go through and you measure each cylinder in this direction, which is your thrust direction. 1, 2, 3. Write them all down, move on to the next cylinder, or like I say, do all the tops, do all the middles, do all the bottoms, do one bank, however you want to do it, however you feel comfortable to do your measuring, because it is a thing that I'm sitting on a little stool here, and you need to get yourself comfortable in a good position where you can actually do this, or that's going to come and bite you back in the bum as well. You're just not going to be happy. And so, as I say, at the end of it, this is what you'll end up with, something like this. And as I mentioned about repeatability and accuracy, I still have slight variances between my final numbers, between my calculated clearance and bore sizes and my measured cylinder bore sizes that I did right at the end, although it is only a very, very minute difference, and I have done them all over and over again a few times. So as I alluded to before, these aren't for machining purposes or anything anyway, it's just for myself so I know what I'm dealing with. So what I've been able to work out from those measurements is that the cylinder block is fine. There's enough meat left on it to re-hone it, and it'll still be in spec for those 87.5mm pistons. It appears to me from the measurements, if my measurements are accurate, which I think they are accurate enough, that the block was honed slightly undersized anyway, and that is the reason that there is that bit of scuffing on a couple of the cylinders, because those cylinders that have the scuffing on them, they are the tightest cylinders going by my measurements. Typically that's sort of what you'll get. I am going to be putting more boost through this engine than it was possibly set up for anyway, because things like cylinder size is dependent on cylinder pressures and expansion rate of your piston. So the more boost you're going to run, the hotter your pistons are going to get, the more they're going to expand, so the more clearance you need in your cylinders. So I will set this engine up with a little bit more clearance than you would with the factory spec for a low boost setting. Like say for example, if you're setting it to run, say, you know, up to about 15 psi, you have to add a certain amount of clearance on top of the factory recommended clearance. All these specifications and clearance amounts are available from your piston manufacturer. In my case it's Wiseco, and they also have specifications in that for, you know, okay, say you're running 30 pounder boost, it'll tell you how much more clearance you need in your cylinders if you're running nitrous, if it's a track car, whatever, and that all relates back to how much heat's going into the pistons. Being that they're forged pistons, they do expand with heat, so you need to adjust your clearances to suit. So as I say, I'm confident I have enough room in the cylinders to hone them back out, to fix up all the anomalies that are in the cylinders, because they do have wear on the top of all of the cylinders, which is usually where you will have wear. The centers will generally, the centers and the bottoms will generally kind of be the best, and the top's usually where you'll kind of show wear. These are like that. You can, from the measurements, you can actually get the actual shape of the cylinder on those two axes, on the thrust side and the non-thrust side. So you can tell whether the cylinders go like this, or whether they're dead straight, or whether they're going out like that, all from your measurements. And at least I have something now that I can take with me when I approach a machine shop about doing work on this cylinder block. I can, you know, they'll obviously probably want the pistons. I can take it in, I can take this in, I can say to them, look, this is what I've got, these are my measurements. Obviously they will want to make their own measurements. And of course, when it comes to either boring or honing the cylinders, you will need to have the main bearing caps fitted and torqued to spec. And it's very good if you have a torque plate for the top to simulate the torque of the head bolts on the top. Not as crucial if you're just honing, if they're existing cylinders. If you've done a re-sleeve or you're boring, then a torque plate becomes more important. Anyway, yeah, so all that sort of stuff's got to be done. I do actually have a set of MazWorks billet caps and billet girdle for the engine block as well. My horsepower goals for this engine, or what I want to build the engine block to be able to sustain, to be able to hold, I'm focusing on building the engine to be able to hold over 1,000 horsepower. It will probably never make that much, but that's the headroom point that I want. I will probably be running it on the street in the 800s possibly, but again, I want headroom in the strength of the engine. So billet main caps and billet girdle, from my understanding, is the way to go. So that bottom end with the forged pistons and forged rods should give me the strength I need for the engine to hold together at that amount of horsepower. Then it's just a matter of making the engine make the power. So how much boost I want to shove into it, and you know, what's going on with the top end of the engine. You know, how much lag I'm willing to cop to be able to get those big numbers at the top. Anyway, that's all for a later date. But as far as the ability for the engine to stay together, it's all about this. It's all about building the bottom end strong. And the way to get the bottom end strong is to use quality components and quality machine work and quality assembly. And this is the first part of how you get that with your build up. It's all about the knowledge, and as we know, knowledge is power. Horsepower. So, as you can see, I'm sort of getting stuck into it. It is a bit of a thing, you know, you can't rush these things. Again, as I say, these measurements, it's all about, for me as well, knowing how I'm going to progress forward with the engine build and what parts I need to order. So with this, it was, you know, whether I need new pistons and all that sort of stuff, you know. So I've got to, now I know that I can get away with just ordering a new set of rings. I've already got bearings ordered and all that sort of stuff. So making these measurements has, you know, given me the ability to kind of push ahead a bit so I can get parts ordered before having to wait to go to the machine shop to get them to measure it, for them to then order parts and all that sort of stuff. It just sort of gives me a bit of a jump ahead, and also gives me the opportunity to, you know, kind of build the motor in my head first, without, you know, getting any bad news from anyone, or, you know, kind of being blown out of the water with anything. I, you know, get a good picture in your own head of what you're doing. Anyway, I'm rambling on now. I need to just shut up. It's getting late. I'm getting very bloody tired. I need to just go to bed and have a bit of a sleep. So, sorry for getting all nerdy with you guys and all numbery and all that sort of stuff, but when you're building engines, that's what it's all about. It's about numbers, precision, planning, all that sort of stuff. So, there'll be more of this coming up if this is your sort of stuff, because I will be going over the entire build here in the Aussie shed. I'll be doing all of it myself, as I do with everything. Yes, I know you probably think I'm an idiot, but that's what I'm doing. So, as always, guys, thanks for stopping by the Aussie Shed. Always a bloody pleasure to have you here. If you like the video, remember to give it a thumbs up. Leave a comment if you can, if you've got any questions about anything that I'm doing, because I've probably just been talking bloody gibberish and not explaining myself very well, which is typical for me. So if you've got any questions about any of the crap that I've been rambling on with, just leave a comment and I'll do my best to sort it out for you. Alright, cheers guys. Bye-bye.